My name is Carolina and I'm from Harmony Public Schools. I'll be presenting my PBL project called Modulated Coil. Historical connection. My physics PBL project is about how sound can be transferred wirelessly from a radio to a tape recorder speaker by using an electromagnet. Through a series of observations, electromagnets were created. In 1820, Hans Christian Ørsted discovered that a current-carrying wire set up a magnetic field. Simultaneously, André-Marie Ampère discovered that a helix of wire acted like a permanent magnet, and Dominique François-Jean Arago found that an iron or a steel bar could be magnetized by putting it inside the helix of current-carrying wire. Finally, William Sturgeon found that leaving the iron inside the coil greatly increased the resulting magnetic field. Sturgeon also bent the iron core into a U shape to bring the poles closer together, thus concentrating the magnetic field lines. However, the relationship between electricity and magnetism wasn't thoroughly studied until 1873, when physicist James Maxwell observed the interaction between positive and negative electrical charges. Maxwell determined that these charges can either attract or repel each other based on their orientation. He was also the first to discover when current passes through a wire, a magnetic field is generated around the wire. My ELA connection consisted of a journal, which successfully provided a platform that reflected on different aspects of my project throughout the experience. The materials I needed were a wire stripper or knife, about 1 meter of insulated wire, a steel bolt, an audio cable, a small radio with headphone jack, and a portable tape cassette player with speaker. Use a wire stripper or knife to remove about 1.2 centimeters of the plastic insulation from each end of the wire. If you have a nut for the bolt, screw it onto the end of the bolt. It may help keep the wire that you're about to wrap onto the bolt in place, but it isn't essential. Start wrapping the wire around the bolt, leaving about 2.5 centimeters of wire free on the starting end of the wire. Begin as close as you can to one end of the bolt and proceed towards the other end. When you reach the other end, start another layer and proceed back toward the original end, but keep wrapping in the same direction. Keep wrapping until you have at least 20 wraps. When finished wrapping, leave another 2.5 centimeters of wire free. Attach the 2 alligator clips on the audio cable to the ends of the wire on the bolt. Turn on the radio and find a radio station with a strong, clear signal. Adjust volume. Plug the phone plug on the audio cable into the headphone jack on the radio. Press the play button. Bring the wire wrap bolt near the head of the tape player.
And if you think that I'm still holding on to something you do,
The radio sends an electric current through the audio cable and through the coils of wire wrapped around the bolt. The wire-wrapped bolt becomes an electromagnet, with the strength of its magnetic field determined in part by the size of the current flowing through the coils. Because the current carries an audio signal, it varies in strength. causing the magnetic field of the electromagnet to vary also. The head of the tape player is essentially a device for detecting very small variations in a magnetic field. Normally, it detects variations in the magnetic field on the audio tape as the tape travels by. In this case, however, it senses the fluctuating magnetic field in the coils of wire wrapped around the bolt.